select the new file from the File menu. Next, disable the Administrator lock. From the Template menu, choose the Tables folder and copy the default geometry to the Model menu. Now we can begin work on the workspace. Select the element box and create a folder named Shafts. After doing this, add the shaft from the Groups section and the elements from the Shaft elements. For this model I have added couplers, gears and bearings. After adding all the desired elements, run the calculations from the Calculations section. Then click OK to save and exit. Repeat the previous steps to add more shafts and elements. Now in order to mesh the gear teeth, select the element box and choose Constraints from the Boundary Conditions section. Then choose the gear pair constraint from the list and select the gear to be constrained. After clicking OK, select the first button in the Calculations section. Follow the same steps for the other gear pair. In order to view the teeth of the gears, select the 3D Geometry option from the top right menu and enable Solid Elements. Now, the geometry is visible. After this step, we have to define the power flow in the system. For this, select the element box and the Speed or Force option in the Calculation menu. Then select the coupler and the desired input speed, enabling speed constraint. Also enable the torque constraint and input the predetermined values. Repeat the following steps for the output shaft, but instead without enabling any options. After doing so, select the diagram box from the menu. This gives the illustration of the power flow in the system. Run all the calculation and see the results. In order to view the animation, select the 3D view from the element box. Then double-click on the 3D view option to generate a 3D model. You can move around and adjust the speed and orientation. This is the final assembly for a generic gearbox. Watch the next video to learn about the gearbox for the project in the Design 2 course.